Hello, everyone. This webinar is a continuation of our continuing series on the Essential Guide to Infrared Imaging. So we'll be talking about the processing and visualization tools for looking at data when you're doing infrared measurements. This will be presented by my colleague Joe Carrick, who sadly won't be able to be with us today. There was a last-minute change, so he has to travel today, but he was kind enough to do some great recording with good audio quality. I'll be here to introduce Telops briefly at the beginning and help with the transitions and answer any questions you may have at the end. So thank you for answering the poll. That was very interesting. The vast majority don't have a direct experience with infrared imaging, but are interested or have considered using that technology. So hopefully this is interesting, and you'll see the potential tools they can use with Telops cameras or infrared imaging in general. Now, Telops was founded in 2000, so more than 2 decades ago. We're based in Quebec City in Canada, lovely town to be in. We employ slightly over 90 employees with different degrees. We really love to focus on R&D. More than half our team is R&D based. We work really hard to maintain our status as world leader in thermal imaging, infrared imaging solution, yes. And as of last year, 2023, Telops is part of the Exosense group. So that's very exciting. Exosense focuses on the large frame, so it's broader broader electromagnetic spectrum, going from visible ultraviolet all the way to neutron imaging. So we're very excited to be part of that family now. Telops has a multitude of different products. Today we'll be focusing on the infrared broadband cameras and a little bit of multispectral cameras. So these are the cameras that we can see from the second point here. So that's multispectral cameras. And then we have the high dynamic range, high performance fast cameras, and the entry-level spark cameras that do offer still a very high level of radiometric accuracy, just at lower speed. The hyperspectral cameras are a very interesting, powerful instrument that is offered by Telops as well, but that is more part of another webinar that we might be. In terms of application, you can do a lot of different research, interesting work with infrared cameras, especially high-level, fast scientific cameras. The main ones that I'm presenting here, but that's just a quick selection of typical applications. Of course, dealing with infrared technology, ballistic and defense applications are a big one. But there's also work for combustion research, looking at the combustion of different gases, either in motor engines or fire combustion. Experimental mechanics is a growing field as well in academia and the industry sector, looking at material properties and mechanical phenomena that are happening at high speed and what kind of heat is created in those phenomena. Gas detection and mineral identification, theoretically possible with multispectral cameras, but we're much more dealing in hyperspectral measurements for this. So less the focus of today's webinar. Otherwise, our signature for the thermal signature or sometimes spectral signature of some fast-moving objects or combustion, that's a big part of what these cameras are used for, of course. Additive manufacturing is very interesting. So that's a sort of newer field of application. And it's been growing quite a lot in the last decade in the industry, just as well as in the academic world. And lastly, non-destructive testing. Of course, when you're trying to inspect either wafers or electronics with infrared cameras, using this, you're able to detect defects or problems in your structure that is not possible to identify using visible cameras. So before I let Joe jump in, I'll mention that what we're talking about in this webinar is valid for broadband cameras, fast cameras, going short wave, mid wave, long wave in the spectrum. So that covers from 1.5 microns all the way to 12 microns. And those visualization tools can be used, and data processing tools can be used for broadband and multispectral cameras just as well. So here, I'll let Joe take over.
Good morning, everyone, and thank you for joining us. As I'm sure Antoine has already mentioned, my name is Joe, and I am a field application engineer for Telops. Today, I have our presentation, Reveal IR, Data Visualization and Image Processing Tools, which will go over Reveal IR's most important functions for the most part, things that you would be very likely to encounter if you ever are to use a Telops camera. This PowerPoint is generally presented for those who may be new to Telops cameras, who may have just purchased one, who may be thinking about purchasing a camera, or perhaps if the camera has sat in your lab for a few years and you've got new students coming to use it. However, I think it will have something interesting for just about everyone. And I would say I encourage everyone to ask questions throughout the question box below. Though I won't be there, Antoine will be happy to answer those at the end of the presentation. So again, thank you for joining us. And with that, I'll take it away. Quick overview to get us started. I will briefly cover the history of Reveal and talk about what it does before getting into some of the data management functions, then the image processing tools. And finally, I will wrap up by showing our new contrast enhancement feature, which was designed to work with our new M700 HDR camera, but also does a great job with older imagery as well. Here we go. Reveal IR was first released in 2018, and it is Telops' proprietary broadband and multispectral data collection, visualization, and image processing software. The current version, Reveal 13, was just released in June of this year. And so we encourage anyone with a Telops camera to send us your serial numbers, and we can check to see if there is a newer version of Reveal that will work with your firmware that we can send you. And Reveal itself, so it collects, obviously, produces and reads Telops HCC files. So what does that mean? You can collect them with your camera. You can export sections of your sequence or post-process data to new data formats, new calibrated data modes, and obviously read them all in the complete package of Reveal IR. Over here on the right, we can see that there are several softwares for our HyperCam and airborne units. However, Reveal IR is an all-encompassing product for the broadband and multispectral cameras. So Reveal is included with all broadband and multispectral cameras. There are no fees or software licenses associated with Reveal. You will be able to install it on as many PCs as you'd like. You won't ever have to pay any extra fees for that. And included in Reveal, in addition to the general data viewing and file producing capabilities, there are several self-contained data processing tools, which I'm going to show a few of a little bit later. And again, you can export to the HCCs as well as movie files, AVIs, ASCIIs, JPEGs, SAF, or CSV files as well. And finally, although I won't cover it today, we do have the ability to export into MATLAB and Python with our data processing toolboxes. They can take the HCC files and bring those into MATLAB and Python very easily. So a lot of folks like that as well.
Okay. So thank you, Joe. Now we'll start by looking at some data management and visualization tools. So I was mentioning that the multispectral and broadband cameras can be used for these tools. So I'll let Joe take over here.
So to start our data management section, we have the sequence selection window of Reveal IR. This is the main panel that opens when you open the program. This is also where you have your camera selection window, where you could connect to your camera and select a calibration prior to starting an acquisition. But here you can see I have several sequences loaded into my projects folders. The first one here is labeled demo, but I have others that are labeled with locations. However, you can organize your data just about any way you'd like in the projects folders. On the next slide, we will open up a sequence. And I've actually got a little video here where you will see me select the sequence I would like to open and then choose an individual frame. I believe it's frame 121. So we don't have to open just to the beginning or the end. And also any other things that we change would be saved. Things like the color palette or scale can be saved from time opening and closing specific sequences. We'll let this play around one more time. But all in all, it is pretty easy to visualize your different HCC files and to open up the specific files and data sequences that you would need. So here I have switched to another sequence. This is a methane burner, just to show you some of the first things that you might do when opening a new sequence. Obviously, lowering the speed for high-speed imagery always helps. We can change to radiometric temperature mode there. We can also pause and go on to adjust the histogram, the applied colors to the data with the sliders there on the bottom. To first choose what I might look towards values on the histogram, I've drawn an ROI line there, which will show me that the peak temperatures are just over 600 degrees, and the lowest temperatures in my flame might be somewhere around 300-400 degrees there. So all in all, this helps adjust the color palette to something a little bit more visually appealing. You see we get a lot of definition there on the horizontal rod that is placed in the flame that is heating up. Can improve the visual quality quite a bit. I know things are moving a little fast there. So here is a screenshot of several ROIs drawn over the top of that burner. And you can even see a zoomed in portion of the individual values of temperature that are found in those pixels in that flame. We also have pulled some histograms, sorry, not histograms, but plots there of max temperature over time, as well as the line profile. I believe that's going to be for the line 1, the vertical line. So you can see the full profiles of temperature over time and across that line. All in all, pretty neat stuff there. But here is a sequence which might show the ROIs in a little bit better detail. So this is an aluminum sample undergoing a tensile strength test that we imaged in coordination with researchers from the University of Rochester. And you'll see here this wave of temperature that rises up the gauge before the sample eventually fractures at the top. That is uncharacteristic for these samples. However, with our full field thermal viewing and our line profile, we are able to see this irregularity in clear detail. So here, normal uniform heating, that's what we'd expect. And then we get this jump in temperature that starts at the bottom of the gauge and rides like a wave all the way up to the top. So there is a great example of how we can use the data visualization and the ROI tools to see something that might otherwise be unseen within our data.
Great. Now, before we jump into processing tools, I'll just jump in to talk about that these visualization tools can actually be used for the same multispectral measurements instead of broadband. So here we have an example of how multispectral measurements would look like in Reveal IR while you're doing the acquisition. So you can see that multispectral cameras, the Telops multispectral cameras can have 8 filters in their filter wheel spinning simultaneously. And while doing the acquisition, you can see the image coming from each of those filters this way. So you can use the same ROIs, the same visualization tools this way within each window. And the processing tools that we'll see in the next few slides can also be used the same way to be used to select specific spectral windows or different spectral windows by combining those specific filters. So I'll let Joe take over after just this little bit to look at how to process the data that you obtain.
So here we have the first of the image processing tools that I'm going to show, and that is the image subtraction function. Our sequence is of a willow near Philadelphia, Pennsylvania, shot with the S1K camera, the shortwave camera. And so most of what we're seeing, actually all of what we're seeing in the image is reflected sunlight. And so as the willow sways, we can actually see the difference in position of the limbs of the tree by subtracting a single frame from the entire sequence that is a reference where the willow is actually pretty still. There's not a lot of wind in this frame. So as you can see, I've selected it there. And on the next slide, I have a video. And so here we have it, the post-processed imagery. And as you can see, the values for the frame on the right there are hovering around 0, where the negative values are actually the older position of the limbs, while the white values are where the branches have moved to. As we zoom in, you can see that a little bit better, sort of the shadows indicating the original position, and the limbs, the new position after the subtraction, indicated by the white values. So all in all, a pretty powerful tool there. Perhaps an even more important tool, however, is our emissivity correction function. So as you may know, our calibration expects the objects our camera is viewing to be black bodies or to have one emissivity, but that is often not the case. So we do have a tool here where you can set the emissivity of your object, and your data will be recalibrated based on that emissivity. So for this experiment, it's cold spray, it's copper pellets that are being impacted onto a metal plate. And we know that emissivity is around 25%. So we can change the emissivity, and you actually see a significant change in temperatures as we activate this emissivity correction, going from somewhere in the 200 to 300 C range to over 500 degrees C by activating this emissivity correction. So it's one powerful tool. A harder challenge is knowing which value to enter into it, knowing the emissivity of your measurement of your objects in your scene. But if you can track down the actual values for emissivity, we do have a correction tool right here in Reveal IR. You don't even need to export your data in order to make that emissivity correction. In addition to the emissivity correction, I don't know if you caught it, so I'll stop it here for you. We also have a various selection of atmospheric compensation that you can do, things like air temperature, external temperature of your optics, visibility, relative humidity. So say if you were operating out in a desert for some reason, you might want to increase the external optics temperature, and internally in the software, processing will be done to adjust your temperature or in-band radiance or in-band irradiance calibrated values based on the values set. Moving on to another tool now. This was sort of the previous generation's best tool for high dynamic range imaging. The new best tool is going to be the M700 HDR, our all-new camera, which I'll briefly talk about here in a little bit. But enhanced high dynamic range imaging is actually something where we are able to vary the exposure time of our collected sequences. We can collect multiple exposure times in sequential fashion, and then recombine both high and low exposure times to produce one single image with good signal to noise and well filling across the image. So for example, here we have a laser welding setup that we collected imagery of with some researchers from the University of Toronto. And we set a low exposure time around 25 microseconds, which was able to capture the actual laser sintering process and the material flow itself. And we also set a high exposure time around 500 microseconds. We were able to see the laser head and the background without all of the noise that you see there in the lower exposure time image. So recombining, we have this beautiful crisp image where we're able to see good detail and have radiometric accuracy in both the high and low temperature portions of our scene.
Great. One little note before I let Joe talk about the new contrast enhancement feature and the new HDR M700. Once again, about the multispectral cameras, I will say there's no point in using the HDR cameras, HDR feature on multispectral cameras. What you can do with a multispectral camera, yes, is using a specific filter wheel set to have a different set of filters that are using different neutral densities. So you have different exposures through the different filters, and that way you can recombine those images manually in the process and the software thereafter. So a different way to do the thing, but you can still do somewhat of an HDR process with a multispectral camera that way. But we'll see how with that new camera, the HDR M700, you can basically get rid of these other features where you can see some amazing images, as I'll let Joe talk about just here.
So here we have it, a sequence from the all-new HDR M700. Here, this is a flambe, a dessert made in the parking lot behind the factory at Telops. All of our engineering friends were very happy to go outside and play with the new camera under these circumstances. What we can see here as I flip on and off the contrast enhancement feature is quite a bit of difference in terms of the background visibility. This was obviously required for the new camera, which is able to view both high and low temperatures at the same time, a wider range up to 900 degrees C at a single exposure time. But it is also quite powerful for older sequences as well, as we'll see here in a minute. But now let me stop this for a second so we can look at some of the... As you can see, I've also applied a different color palette. But here we have the full scope of the range of temperatures in the one scene, all visualized with different repeated colors. However, you can see the whitest portions of the flame there are over 450, over 500 degrees C, while the body temperatures and the temperatures of the bowl and the bottle of liqueur in the background are obviously much closer to ambient. If it was a warm day, it was probably 30 C or so on the table there. But still, great definition across the board, which would otherwise not be possible without our all-new contrast enhancement function. And this contrast enhancement works very well on older sequences as well. Here's a sequence from our M3 SHD. So this is just our standard traditional mid-wave broadband camera in a high definition, a large FBA. But you can see here this image of the Holland America Line cruise ship up in Quebec City as it was docking to pick up some passengers. All in all, it looks pretty nice, but when we flip on the contrast enhancement, we get a considerable amount more definition. You can start to see things like the variance in the hull, where there might be structural pieces behind the wall. It's very clear to see why the windows were placed where they were in between such paneling. Also, you can see a lot of definition in the brickwork on all of the buildings in the foreground, as well as in the trees on the far side that's across the St. Lawrence River. Quite a bit of definition increase across these colors. So obviously, it does spread the color scale to a point where multiple colors may indicate multiple temperatures in the scene. So you do have to be wary of that. But between the two, between the original image and this contrast enhanced image, you're able to pull out quite a significant amount of detail just in the base features of Reveal IR. And so with that, that's actually what I have for you today. Again, this was a very brief, I guess we could call it an introductory tour to some of the features and tools that come standard in Reveal IR. But I hope you learned a few things. I hope you started to see some things that you might be able to do with your own research, with your own applications. And I also hope that there are some questions in the question box. So with that, I will turn it back to Antoine, who will be able to help answer some of these questions. And please, if you come up with questions in the coming days, do send them to us. We have the email here, sales@telops.com, but also FAE, stands for Field Application Engineer, but FAE@telops.com. That'll be seen by Antoine and I. So again, we appreciate you joining us today, and thank you for your time.
Great, thank you very much, Joe. So like Joe said, this is more of an introductory webinar on the tools that can be used. Of course, for more advanced measurements, for more advanced users, there's a whole series of different functions that can be used, more in particular in MATLAB and Python, like Joe mentioned. So that's, of course, every user, every application has its own way of processing. So it's more on a case-by-case basis. But we can see here a good amount of processing and visualization that can be done directly within the software, which all of this can be exported afterwards to process a bit more in detail. So let's see questions that we might have down here. Okay. So yes, so the measurements that we showed today, that was all taken with Reveal IR. If you have experience with other cameras other than Telops, feel free to talk to us if you're interested in another type of measurements with maybe faster cameras or multispectral cameras that Telops is specialized in. The HDR camera as well offers a really revolutionary way to image scenes in infrared, which was never possible to do before. To use Reveal IR, it's done through using the Telops cameras. We have the .htc proprietary files, like Joe mentioned, which are vectorial format. So the main question was how it could be used on other camera sequences. Basically, it has to use the HCC files, the Telops proprietary files. Would it be possible to convert those files into a vectorial file in MATLAB, for instance, and then reconvert that into an HCC file to be used in Reveal IR? Possibly. I think that there might be something to do with that, but there's a certain amount of hidden headers in the .hec files that would have to be created through those MATLAB functions. I don't see that being impossible, but probably have to work a little bit with the R&D and development team to see if it's possible. All right. Any other questions about either the software or data processing? Okay, there we go. Can it detect water leakage from home cemented floor? Interesting. I feel like I need a little bit of clarification for that kind of question, but if we're talking water leakages from home cemented floor, we're talking about water that's not, I imagine, visible with our eye or with visible cameras. It's all a question of what kind of emission we're expecting, or kind of absorption or reflection we have from that kind of scene. I imagine water leakage that happened before would leave some sort of residue that we might be able to identify with either shortwave through some reflectance measurement, or in the long wave to have those lower temperature measurements. In terms of spectral analysis, then we're dealing more with multispectral cameras or hyperspectral cameras. Multispectral cameras, it's easier to do that higher temperature. Hyperspectral, then we get that proper signature really in the measurement, even if you're at lower temperature. Otherwise, I would probably need a little bit more information. Feel free to write to us to discuss this a bit more in detail. Okay. So if you have more questions, feel free to write to us. We'll send a version of the video version of the webinar and PDF version if you registered for the webinar, and a list of all the questions that will have been answered, even if you send some questions afterwards when I'm done. So once again, thank you very much for attending. I hope you enjoyed the webinar and learned a little bit on the way to visualize and process data with Reveal IR. I'm Antoine Dumont, field application with Telops. Joe, my colleague, same as a field application engineer. And thank you very much and have a good day.